Alright, solving systems algebraically, section 3.2. We are looking at today using the substitution and elimination method. When we talk about solving systems, there are three different methods. You can do it by graphing, which is what you did last week on Wednesday. And then there's also substitution and elimination. Alright, both the methods today are usually what students typically use to solve. A lot of times they're just easier than graphing. A little more, sometimes they involve a little more work, but students can see the answers a little better. So solving systems algebraically, section 3.2. First off, we're going to talk about the substitution method. Now they have here, there are 6 different steps. I kind of condensed it into 3 later. But substitution method is used when you solve for one of the variables. Okay? Now, when we take a quiz and test, you can use any method you want to solve these out. That's not a problem. But some problems will be set up to work them out a specific way. Like, for example, a problem like this. This is set up to use substitution. Because y equals x plus 2 here. And again, y equals all of that. So to use substitution, I'm taking all of that and I'm going to replace y. So again, I take all of that, replace y, and that's what comes down here. So you get 2x plus x plus 2 because I'm substituting for y. Now that eliminates a variable in which I can solve for x. You get x equals 5. Once you have one of the variables solved for, then you simply plug it in for that variable. So I plug it right back in. You get y equals 5 plus 2, y equals 7. Now a lot of students want to stop right there when they get their answer. That's not the answer. Because we're talking about an x and a y on the coordinate plane, our answer is always going to be an ordered pair. For example, 5, 7. That is our answer. Don't say x equals 5, y equals 7. I want the ordered pair answers. For example, on the quiz, if you do not have these parentheses right here, that's like a point off already. Okay, you got to make sure you put those parentheses. It is an ordered pair. And then as always, you can always check just to make sure you're doing these right. Plugging them back in, making sure it works. You know, for example, 7 equals 5 plus 2. 2 times 5 plus 7 equals 17. It checks out for both of them. And that's what it will always be. It will always be something that checks out for both. Alright, let's try the first one. This is probably the toughest one you'll have today. So I have 4x plus 3y equals 4 and 2x minus y equals 7. I want to solve for one of the variables. So step 1, solve for one of the variables. Now if you look through there, I have 2 equations and 4 different variables technically, the x and y on the top and the x and y on the bottom. Which one is probably the easiest to solve for? Or it'd be a lot easier than any other one? Phil, what do you think? Which one is, would you say, I'd probably want to solve for that variable? The bottom one and the which one? The x or the y? The y. Why would you say that one? I agree. It's all by itself, really. I would definitely want to solve that. I don't have to do really any division by numbers. I'm not going to get any fractions. Much easier. So I'm going to solve for y. So 2x minus y equals 7. I'm going to solve for y there, get y alone. Subtract 2x on both sides. Negative y equals negative 2x plus 7. Divide by negative 1. And I get y equals 2x minus 7. I solved for y now. So I have y equals 2x minus 7. Great, got that first step. We're good. I solved for one of the variables. Now step 2 says substitute the expression into the other equation. What does y equal here, Colin? Y equals what? In the one that's highlighted there, what's y equal? The whole thing.
Okay, 2x minus 7.
Y equals 2x minus 7. So what am I going to substitute in?
2x minus 7.
I'm going to substitute that in for y. That's my substitution part. I get what y equals. All of that will now substitute into my other equation. So I get 4x plus 3 parentheses is key on these, 2x minus 7 equals 4. I substituted all of it, not just the first part, not just the end. I substitute all of it into that other equation. Now I have just x's. Now I can solve. Well, I would distribute, giving me 4x plus 6x minus 21 equals 4. 4x plus 6x, I get 10x minus 21 equals 4. I'm just solving for x here. Add 21. 10x equals 25. Divide by 10. Now I'm going to get x to equal 25 over 10, 2.5, or 2.5, 5 halves, all the same thing. I'm going to leave it as 5 halves, just because I like improper fractions. But yeah, 2.5, 2.5, all the same thing. I get x equals 5 halves. Now again, what's the plus side of being able to do this? Well, if you're doing this by graphing, it's kind of tough to find probably 5.5 graphing, isn't it? You know, it's kind of in between. It's not always at one of those intersection points. So that's why substitution is nice. Step 3, substitute the value from step 2 into either equation. So I can substitute this value into either the top or the bottom equation. Which one might be easier? Now again, it doesn't really matter, but some of them are easier than others. Which one do you say might be easier, Sean? Good. So we're going to plug it right in here for that bottom equation. Y equals 2x minus 7 because y is already solved for. So y equals 2 parentheses 5 halves close parentheses minus 7. Good work. 2 times 5 halves, my 2's just kind of cancel there, right? It's cross multiplication. So I'm left with y equals 5 minus 7, which then y equals 5 minus 7 is negative 2. So I have my x, I have my y. Am I done, Andy? Am I? No, what do I have to do? Write the ordered pair. What's my ordered pair then? 2.5 negative 2 is my answer now. Nice job. All right, again, as somebody said earlier today, yeah, that's a lot of work for a small answer, but, certain problems are set up for substitution and it makes them easier. When we do elimination later, maybe you can do elimination on a problem like this. That's okay. But we'll do a lot of the different methods, and then you can kind of use whatever method you want to your strength. Okay. Let's try number 2 here. I have 2x minus 3y equals 6 and x plus y equals negative 12. Now when I'm looking at solving for a variable, first step says to solve for a variable. Which equation would be a lot easier, the top one or the bottom one? What do you think, Sage? The top or the bottom equation? The bottom equation would be a heck of a lot easier. Which one would you want to solve for in that bottom equation, Sage? It doesn't matter. Which one?
Y.
Let's go for the y. So we're going to solve for the y. So what do I have to do first, Sage? Subtract x, getting me y equals negative x minus 12. Good work. What does y equal there then, Sophie? Negative x minus 12. So what am I going to substitute in place of y, Sophie? Negative x minus 12, right? So I'm going to take that and I'm going to substitute it right in, giving me now 2x minus 3 parentheses negative x minus 12. Again, recognizing when I plug it in, plugging it in those parentheses so I can recognize when I need to distribute. Now, do I need to distribute here, Jack?
Yeah.
What do I need to distribute on this one, more importantly? Yes, I need to distribute this negative 3. So I get 2x plus 3x plus 36 equals 6. Recognize I took the negative 3 to everything. From here I solve for x. 2x plus 3x, I get 5x plus 36 equals 6. I get 5x equals negative 30. Divide by 5. And x comes out to be negative 30 divided by 5, Reagan? Negative 6. Good work. I have negative 6 here. What am I going to plug that into now, Jarrett?
The equation.
Which one?
X plus y equals 12.
Okay, good. We can plug it in right there. So I get negative 6 plus y equals negative 12, right? What would you do then, Jarrett?
Subtract y.
We're going to solve for y.
Oh, yeah, sorry. Add 6.
Add 6. Good work, sir. And I get y equals negative 12 plus 6, Jarrett.
Negative 6.
Do I have my answer now?
No.
Nope. What's my answer?
In parentheses, and negative 6. My negative 6.
Now I have my answer. Recognize that as a coordinate. That's an ordered pair. Negative 6, negative 6. And again, when you start getting the hang of these, they really don't go as long as what they look like. Once you start getting the hang of, I can start multiplying, I can add and subtract, it's really not that bad. All right, next problem here. Now this one is set up perfectly for substitution. This is a perfect substitution type problem. Why would you say that, Sean? Y is already by itself. This is one that right away you would say, ooh, substitution is by far the easiest method. So I take that and I substitute that in place of y. Work that one out from there. Through this one, see how you did. So when you substitute in, you get 4x plus 3, parentheses 3x equals 26. So 3 times 3x is 9x. 4x plus 9x equals 26. Gives me 13x equals 26. X equals 2. And then from there, it's kind of set up. Which one's by far the easier one to plug into, Phil? Yeah, the first one. It's already solved for y there. So I get y equals what then, Phil?
6.
And my answer is what then, Jack?
2, 6.
Nice job, sir. 2, 6 is correct. All right, take a couple seconds here. Try number 4. Now again, you can solve for either one. It does not matter. Solve for one of the variables, substitute in, work it out. All right, I'm going to walk through here. If I would have solved for one, I would have solved for the first one, giving me y equals negative 2x plus 100. I just would have solved for that one, just a smaller x variable. All the same. Substitute that in. So substitute negative 2x plus 100 in for y. Giving me 6x plus the negative 2x plus 100, which then gets me 4x equals 100 divided by 4. X equals 25. From there, I can plug it in. I would again choose that top equation, giving me 50 plus y equals 100. Subtract 50, and you get y equals 50. My answer then is what, Reagan? 2550 is correct. Now again, substitution. Typically a lot of work on some of these problems if they're not set up in order for substitution. If they're set up like substitution, like number 3 was, pretty straightforward answers on these, right? But the other method we're going to talk about, which is typically everybody's favorite, is the elimination method. All right, now in order to eliminate variables, we add or subtract. We're just going to add. We're not going to do the subtraction part. We're going to look to add. In order to use elimination, you have to have a setup like this. As in, they have the same number coefficients and opposite signs or different signs. Okay, because what happens here is when I have a positive 2y and a negative 2y, I can then eliminate by adding down and eliminate my variables. Well, that gets me then 3x plus 5x is 8x. 7 plus 1 is 8. I can solve for x, which is 1. So the first part's different. The second part's still the same. Once I have a variable, I then just plug it back in to get your second variable, and then your answer is still going to be an ordered pair. But here is all the key right here. You have to have the setup. So that has to have the same coefficient, different signs. Then you just add down and you eliminate the variable. Henceforth, why it's called elimination method. Again, this is usually people's favorites because it's a lot easier. You eliminate it, a lot less work. Okay, number 5. So I want to solve by elimination. 4x minus 2y equals 7. X plus 2y equals 3. This is a perfect elimination problem. Why, Andy? Which variable is set up to eliminate? The y. Negative 2y, positive 2y. If you look there, they are set up to eliminate. So I eliminate the variables, and I add down. So 4x plus x gets me 5x. 7 plus 3 equals 10. I have 5x equals 10. From there, I solve for x. What's x have to equal then, Colin? 2. Nice job. X equals 2. A lot less work on those problems, isn't it? Now, the second step, or the third step, is going to be the exact same thing. I can plug one in. Should I plug it into the first equation or second equation? Now, again, one is easier than the other, usually. Which one might be easier? Jack, what do you say?
The bottom one.
I would plug in the bottom one. Nice job. There's positives, less multiplication, definitely. So 2 plus 2y equals 3. Again, plugging it in for that x. And from there, just solve for y. Subtract 2 on both sides. Giving me 2y equals 1. Divide by 2. I get y equals 1/2. Now I need to write my answer. What's my answer going to be, Sage?
2.
Nice job. And that is my answer. Now again, elimination. As long as they are set up to eliminate, it can be a lot less work for you. Okay, but not all problems will be set up that way. Let's try number 6 here. 3x minus 2y equals 14. 2x plus 2y equals 6. Which variables would I like to eliminate, Bailey? Yeah, the y's. I have a -2 and a +2. So they are set up to perfectly eliminate by adding down. So 3x plus 2x gets me 5x. 14 plus 6 equals 20. I have 5x equals 20. Divide both sides by 5. Shane, what's 20 divided by 5? X equals 4. Nice job, sir. I have one of my answers there, or part of my answer. Now I need to plug it in. Which one would you like to plug it into, Mark? The top equation or the bottom equation? Now there is a right answer and a wrong answer here. Good. Why would you say the bottom's easier?
They're all positive.
They're all positive. Exactly true. Anytime there's negative, it just kind of throws you off sometimes. So let's just plug it into where it's positive. So I plug it in right there. 2 times 4 gives me 8 plus 2y equals 6. Subtract 8. 2y equals -2. Divide by 2. And I get y equals a -1. What's my answer going to be then, Sophie? What? What's my x value? Right there? 4, comma, -1. And that is now my answer, 4, -1. Number 7, for some reason, I didn't realize. It's the exact same problem. So you will get the exact same answer. It's 4, -1. You can try it again, though, if you don't believe me, Colin. Number 8. Okay, a little different here. Now again, in order to eliminate, we want to have the same coefficient, but opposite signs. Why? Because then you can just add down. This one, if you look here, I have the same coefficient. They are not opposite signs, though. So what is something I can do to change one of the equations? What can I multiply everything by and change it? How can I get a negative on that? All that? Anybody? Very good. I can multiply everything. Now I'm going to choose the second one. It doesn't matter which one. But I can change everything by multiplying the whole equation by a -1. Now, does that change the equation? No, it's going to be the exact same equation because I'm doing it to everything in there. So now this becomes -4x minus 6y equals a +2. Making everything the opposite sign is just like flipping it all to the other side of the equation, essentially. Changing everything, multiplying all by -1. Now can I eliminate my variables, Colin? Yes, now I can eliminate my x's, giving me 9y minus 6y. So I have 3y equals 1 plus 2 is 3. 3y equals 3. Divide by 3 there. And I get y to come out and be 1. Now from there, which equation would you want to plug it back into? Top or bottom one, Jarrett? You can plug in the bottom. So you're going to plug in the bottom one?
Yeah.
Okay, oops. So I'll plug in the bottom one right there. So I get 4x plus 6 equals negative 2. Do you agree? 6 times 1 is 6. Subtract 6. 4x equals a negative 8. Divide by 4. And I get x to be what, Jarrett?
2.
Negative 2. Which then means my answer is going to be what, Jack?
Negative 2, 1.
Negative 2, 1. Nice work, sir. That is correct. And again, how can we get that? Because we can multiply an equation by a negative number. You can multiply an equation all by a positive number as well, too, to change it, if you'd like. All right, number 9. I'm going to help you get started here, and then I want you to work it out on your own. If you notice here, I am almost set up to eliminate. What do I have to do on number 9 in order to set them up to eliminate? Sean? Which one would probably be easier? There's a right answer and a wrong answer here. Or a easier answer and a harder answer. Which one are you going to multiply by negative 1, the top or bottom? You're going to go at the bottom? You like difficultness, huh? Why would the top be easier? Does anybody know why?
Because it equals 0.
Because it's 0, so I really don't have to change that one. Does that make sense? I would do the top one. You know, if Sean wants to be more difficult, work a little harder, go for it, man. By all means. So then I get negative 5x minus y equals 0. Still 0. That just makes that one easier. Now from there, work it out. All right, give me what you have for an answer, Phil?
Negative 6 and 30.
Negative 6 and 30 is correct. Nice job. When you eliminate your x's here, you're actually left with y equals 30, which makes it pretty simple. You can then plug it right back in, and you get x equals negative 6. Good work. All right, last problem we're going to look at. And we're just going to look at how you would set it up, and then you can work it out from there if you need to. But if you notice here, I have 3x plus 7y equals 15, and 5x plus 2y equals negative 4. None of them are set up to eliminate. But remember, I can multiply. Andy, which one would you like to eliminate, x's or y's? X. Okay, so I'm going to eliminate x. So I want to find a common multiple. Andy, what's a common multiple for 3 and 5? 15. So the first equation, I'm going to multiply everything by 5. So I can get to that 15. So I get 15x plus 35y equals 75. Oops. Now, on the second equation, that means I have to multiply the second equation by what, Andy? Ooh, not just 3, but actually negative 3. Because I want to have it to the opposite sign, right? So now I get negative 15x minus 6y equals 12. Now I'm set up to eliminate here. So recognize, I can use elimination when they don't look to be set up by multiplying by a constant. If you look up there, I multiplied everything in the first one by 5, everything in the second one by negative 3. Now I can eliminate my x's, leaving me with 29y equals, was that 87? 29y equals 87. When you work that out, divide by 29. I believe you get y equals what, Phil? I think you had it. Y equals 3. Nice job. So again, I can set them up to eliminate. Big key on a problem like this. Because if you don't realize this, well, substitution is kind of your next best choice, and that looks really rough for substitution. You're going to get a lot of fractions and improper fractions and mixed numbers. I then plug y in here. 5x plus 6 equals negative 4, minus the 6 over. 5x equals negative 10. I get x to be what, Jack? Negative 10 divided by 5? Negative 2. Which means my answer now is negative 2, 3. Again, this is the key right here. Recognizing that you can change them by multiplying by constant throughout. Alright? Here is your assignment. This is the Blackboard assignment.